Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Polyphosphoric acid, PPA, is a strong acid catalyst used for intramolecular Friedel-Crafts acylation and acid-catalyzed cyclization reactions. In this case, PPA promotes an intramolecular electrophilic cyclization, Nazarov type or acid-catalyzed intramolecular aldol cyclization. Step 1. Identify the starting material. The substrate is E1-cyclohex-2N1-Vial 3-phenylprop-2N1-1. It contains a cyclohexene ring with a double bond and a conjugated enone side chain, C is equal to O, CH is equal to CH, pH. Step 2. Role of PPA. PPA protonates the carbonyl oxygen of the enone, generating a vinyl cation oxocarbenium intermediate, or alternatively activates the double bond toward electrophilic cyclization. The key reaction here is an intramolecular Nazarov type electrocyclization or acid-catalyzed intramolecular Michael aldol cyclization. Step 3. Nazarov cyclization rationale. The divinyl ketone moiety, cyclohexene double bond conjugated through the carbonyl with the STYR-vial double bond, undergoes a 4-pi electrocyclic ring closure under acid catalysis. The two terminal carbons of the cross-conjugated diene system form a new C bond, generating a cyclopentenyl cation, which loses a proton to give the cyclopentene product. Step 4. Product formation. The intramolecular cyclization between the terminal carbon of the cinnamol double bond, bearing pH, and the cyclohexene double bond carbon forms a new 5-membered ring fused to the cyclohexane ring, giving a bicyclo 4.3.0 hydrindane indenone skeleton. The resulting product is 2-phenyl-2,3,3,A,4,5,6,7,7A octahydro 1H indane 1-1, a cyclopentane ring with pH on the double bond fused to cyclohexane, i.e. option B. Step 5. Why other options fail? A. No carbonyl present. Loss of carbonyl is not expected under these mild cyclization conditions. C. Would require Friedel-Crafts acylation onto the benzene ring of pH and ring expansion, which is not favored here. The pH group is not positioned for intramolecular acylation onto itself in a way that gives a 7-membered ring. D. Represents a retro or fragmentation product. PPA promotes cyclization, not ring opening. Therefore, the correct answer is B. Therefore, the correct answer is option B.